Okay, pre-calculus 12, let's get after it. Here we go with division of polynomials. And what we're going to do is we're going to look at everyone's favorite long division. You're going to see how that process works out. And then what we're going to do is we're going to introduce a more straightforward, simplified version called synthetic division. Now, synthetic division has a process to it, and the process is nicely outlined in the notes package found on my website for section 3.3. I'm not going to go into the process in abstract here, but I am just going to use the process in a couple examples. So you'll see it in action, but if you want to look at a little bit more detail, feel free to check out the notes on the website, mrherlar.weebly.com. So here we go. Long division. So here we have a polynomial. Okay, it's a cubic, power 3, and we're given a root or a factor, right? If the root is x equals 2, then the factor is x minus 2. And what that means then is that means we must be able to factor out or divide our polynomial by our factor. And now what we're looking for is we're looking to line up our x values. So you're putting an x squared value on top of an x squared and an x on top of an x and so on and so forth. And we're water bombing our value into our factor and then writing it underneath, just like we would normally do with long division. So here's what I mean by that. I'm looking for a number that multiplies by x to give me 6x cubed. So that number is going to be 6x squared. I want that 6x cubed to cancel out. So 6x squared times x is 6x cubed. 6x squared times negative 2 is negative 12x squared. And now I do my division. So my 6x cubes are going to cancel out, or sorry, I do my subtraction. 6x cubes are going to cancel out. Now it's important to remember that subtraction because negative 19 minus negative 12, that's often where errors occur, is negative 7x squared. You bring down your 11x, just like we would do on traditional long division. And now we got to get rid of a negative 7x squared. So I'm just going to go with negative 7x because that's going to give me the same sort of water bombing into the x minus 2. Negative 7x times x is negative 7x squared. And then I get positive 14x. Do my subtraction and I'm left with negative 3x plus 6, and I'm looking to get rid of that negative 3x, so I'm just going to throw a minus 3 up here, and I get negative 3x, and then here something great happens. I get a remainder of 0. Now, I should expect a remainder of 0 here because I'm told that that's a factor. So I should know that this polynomial is equal to my factor times my result, which is technically another factor. And then what you can do with this answer is you can factor it as well. Now, this one is factorable using the AC method or using factor by grouping. I'm not going to do that here. I'll let you do that. You could also use the quadratic equation, but this breaks down to 2x minus 3 and 3x plus 1. So now you have your cubic fully factored. And that way you can find the roots, and that's the whole point. We're living good, we're happy. So let's do another one. So here we have 3x cubed plus 2x squared plus, or minus 2x squared plus 1. Now, something happens in this scenario. Okay, we are missing the x term. There is no x term. So we need to make sure we plug that in with respect to 0. So 3x squared minus 2, or 3x cubed minus 2x squared, but now plus 0x. You need that in there to keep the placeholder system in line. And then plus 1. And now again, we have x minus 2. Now, notice in this case, we're not being told that x minus 2 is a factor. We're just dividing it by x minus 2. So if we get a remainder of 0, it's a factor. If we don't get a remainder of 0, then we have a problem. Well, we don't have a problem. We just have a remainder. So let's look and see what we have then. Okay, I need first a 3x squared because I need that 3x cubed gone. So now I'm going to have 3x cubed minus 6x squared, do my subtraction, and I'm left with 4x squared. And yeah, bring down a 0x. So now my goal is to get rid of that 4x squared, so I'm going to add 4x. I end up with 4x squared, and in this case, minus 8x. And here's, watch your subtraction. 0 minus negative 8 is 8x, plus 1. Now, if you're proactively looking at this going, I need something that multiplies to 8x and then to 1, it's not going to happen. Well, your goal is to get rid of that 8x first. So plus 8, because now you get 8x, and then, yeah, you get minus 16, which leaves us a remainder of 17. What that tells us is that x minus 2 is not a factor of my polynomial. And just how we write this down, I mean, we can still say we divided it. We have our original polynomial, and I don't have room, so I'm going to write it below. And that is equal to, the order doesn't necessarily matter here, my result times my given factor, but then plus, since that's a positive 17, 17. You have this extra 17 hanging around. And you would notice that if you did distributivity here and you multiplied the 2 or x minus 2 back in, and then you added 17, you'd get back to our 3x cubed minus 2x plus 1. That's the whole point. Now, there is a way of writing this where we remove the factor from the left side of the equation. So if we divide everything by the factor of x minus 2, we end up with an equation that looks like this. And this is just a different piece of notation, nothing to stress yourself out about. And then plus 17 over x minus 2. Because what we've done is I'm going to erase that distributivity word here. What we've done is we've essentially divided every statement by our factor, and then we did it here as well. And it's just a way of demonstrating that we divided this by this, and we ended up with this and our remainder, but our remainder includes being divided by that factor. So that's long division. Let's do one more. Now in this case, we have a rather large divisor. So we have 3x to the 4 minus, oh, careful, got ahead of myself. Put this in descending order so you can see if you're missing any powers. And we are in fact missing an x term again. So 3x to the 4 plus 2x cubed minus 5x squared plus 0x minus 1. And we're dividing by x squared minus 2x plus 3. And there's nothing new, different, or scary about this. It just means we're now water bombing our value that we're picking into every term inside of our factor. So I'm starting with an x squared term because x squared times x squared will give me this x to the 4 term. So I'm starting with a 3x squared because that's going to multiply into each thing over there. So I'm going to end up with 3x to the 4 minus 6x cubed plus 9x squared. And now you still do your subtraction, you just end up with more things. So the 3x to the 4's cancel out, 2 minus, so I'm left with 8x cubed minus 14x squared, and then, yeah, bring down that 0. Now in this case, your goal is always to get rid of your leading term. So I'm going to multiply this by plus 8x, because that's going to guarantee me here this 8x cubed, and then end up with negative 16x squared and 24x. Do my subtraction, and now I have 2x squared minus 24x, and then I bring my negative 1 down. So my last thing, and again, the goal is to at least get rid of your leading term, so it's going to be plus 2. And if this works, if it was a factor, we'd get a remainder of 0. But what do we get here? We get a remainder of something that is most definitely not 0. We get negative 20x minus 7. So we would say 3x to the 4 plus 2x cubed minus 5x squared minus 1. You don't need the 0 when you're writing your statement, equals our factor times our result. I'm going to run out of room here, but in this case, I'm going to say plus, in brackets, negative 20x minus 7. But if you were to factor out a negative, you could also say, I'll do it in yellow, you could say minus 20x plus 7. Same statement, we've just factored out a negative. But generally, we prefer the plus only because it demonstrates that you are adding a remainder. So that's long division. Now, you might be thinking, there's got to be an easier way to do this. And indeed there is. It's called synthetic division. So again, in the notes, there's a step-by-step breakdown, but the way synthetic division works is if we're dividing by this factor, that means x equals 2. So what we do is we set up this little half table and we put our factor, not the minus 2, but we put what x is equal to in the top left. And then we list the coefficients only of our values, but again, be wary that if you're missing an x value, you need it as well, right? So an x cubed or an x squared if you're missing one. So what we end up writing in the row is we write positive 3, and we write negative 2, and then we put a 0, and then we put a positive 1. That's the coefficients of our terms in descending order. And now you drop your first term, you don't do anything to it, you bring it down here. You then multiply it by the number, the factor, the root that's in front, and you write the result underneath the next number. So 3 times 2 is 6. And now in this case, we're adding these rows together. So now negative 2 plus 6 gives us 4. And then we repeat that process. 4 times 2 is 8. 0 plus 8 is 8. Then we repeat that process. 8 times 2 is 16, and then we add that together. We get 17. And here is your answer. Now, this cutoff, this is your remainder. When you get a 0 there, it means you have a root. And you're going to see that in the next section often. And then what you get here is whatever power this was, whatever degree that term was, that was an x cubed degree. This is 1 less, so that'll be x squared. So we end up with x minus 2 as our given factor, and then we just take the values from this bottom row. So we end up with 3x squared plus 4x plus 8, and then we have a remainder there of plus 17. And you'll see that that's exactly the same as what we got here. Or sorry, which one? Here, right? Using long division, there was our answer, there was our remainder. We did the same thing using synthetic division. So you can see that synthetic division is quite a bit faster, quite a bit cleaner. I mean, I drew squiggles all over this page, but just more approachable. So you'll get really comfortable with synthetic, and you'll, I'm hoping, prefer it over long division. There's nothing wrong with long division. I quite enjoy long division, but synthetic division is just more straightforward for this process. So let's do another. Now, what are we missing? We're missing an x to the 4 term. We're missing an x squared term, so be aware of that. So when you set up your synthetic division box now, we're going to have 4, 0, and then negative 30, the sign in front of a number belongs to it, and then 0, and then negative 50, and then 2. Now normally you want to make sure you give yourself enough room. I barely gave myself enough room, but we'll go from here. Now, I'm dividing by x plus 3, which means I put a negative 3 here, put the opposite, right? Put my x value that makes it 0 in there. Drop my 4, and now I do my multiplication. So negative 12. Add those together. Negative 12 times negative 3 is 36. Add those together. 6 times 3 is negative 18. Add those together. Negative 18 times negative 3 is 54. Add those together. 4 times negative 3 is negative 12. Add those together, you get negative 10. So remember, that is your remainder. So we can say that 4x to the 5th minus 30x cubed minus 50x plus 2 divided by x plus 3 equals, remember we drop 1 power, so 4x to the 4 minus 12x cubed plus 6x squared minus 18x plus 4, I'm just going to draw a little line so we, and then our remainder is negative 10. So minus 10. But in this case, see, I've divided by x plus 3. So my notation is this notation. That remainder is also being divided by x plus 3. You could have it written the other way, which I'll write just below here. You could have just 4x to the 5 minus 30x cubed minus 50x plus 2 equals, and then you do your x plus 3 times 4x to the 4 minus 12x cubed plus 6x squared minus 18x plus 4, and then minus 10. You could write it like that as well. Either one is good. So again, synthetic division makes life quite a bit easier. Now, obviously, there's a little bit of exploratory caveats going on here. It's not always going to be straightforward. And number one is when you have a factor that is 2x minus 1. So you have to consider, remember that if you have 0 equals 2x minus 1, it means your factor is actually x equals a half. So what we're going to do with our synthetic division is we're going to have to put a half up here. And then we still list this the same way. We're not missing any power terms. So 6 minus 7 plus 4 minus 11 plus 9. So now we'll do the synthetic division. I'm going to do this relatively quickly because at this point I think you know what's happening, or at least I hope. And we end up with this. So you end up with, let me just think how to best phrase this. You end up with this scenario, right? 6x to the 4 minus 7x cubed plus 4x squared. Keep going. Minus 11x plus 9 divided by 6x cubed minus 4x squared plus 2x minus 10 plus 4 over x minus a half. Now, the thing is technically our factor is 2x minus 1. So our answer needs to look slightly different because we've used a factor of x equals a half, which is true, but it's not written as 2x minus 1. So what you need to do is you need to take your entire equation. So this, and then this, and multiply everything by 2 in the denominator. Because then what we get is we get 2x minus 1 down here. We get 2x minus 1 down here, so it's true to our factor. And then the only thing that changes is this. So we get 3x cubed minus 2x squared plus x minus 5. And that is what we call the missing factor. So we need that in there because we're missing a factor of 2. So that is our actual solution. Okay? That's the caveat there. You got to be careful when you have that set up because the coefficient in the divisor has to be x. So if you were using long division, you wouldn't have to worry about this issue. But when you're using synthetic division, you do. So let's do one more. And it's similar setup, except here we have x squared minus 4. So in synthetic division, you can't throw that value in there, so you need to factor your factor, which in this case is a difference of squares. What that means is that gives us two factors. That gives us the factor x equals negative 2 and x equals positive 2. So you have to use both. We're going to do this in 2 steps. I'll show you what that looks like. So again, we're not missing any degree values. So we have 1, 9, minus 5, minus 36, and 4. And what I'm going to do is I'm going to start with x equals positive 2. I'm going to do this one first. And what I get is okay, 1 comes down, multiply by 2, add, I get 11, 22, add, I get 17, 34, add, I get negative 2, and then I get a remainder of 0, which is what I would expect because it's a factor. And we're assuming at this point that we're trying to find factors. So if it's a factor, great. And the fact that I'm dividing by this, if this whole thing is a factor, then obviously both the individual 2 and negative 2's also have to be factors. So that's great. But we have another factor. We have the factor x equals negative 2. So what you can do is you can just take this result you have and run the same thing again, except you disregard your remainder. But now we're running it with negative 2. So the 1 comes down, you get negative 2, 9, negative 18, negative 1, and then 2, great, again, remainder of 0, which we expect because we know we have a factor of x minus 2, x plus 2, and then all that matters is this last chunk, which is going to be a quadratic because we started with a power 4, right? It's original power 4, so that's a power 3, so that's a power 2. And we get x squared plus 9x minus 1. Not easily factorable. You could check a quadratic equation, but it's possible that it doesn't factor out either. So we'll leave our solution there. And you could do the notation in any way you like, but for the sake of this question, I'm just going to leave it there. And it's equal to our x to the power of 4 starting polynomial. So that is how you can factor a larger polynomial, particularly if you're being told that this is a factor. You could be told something, for instance, like you have a large polynomial and you're dividing it by, let's say, what do I want here? -10, yeah. So let's say this is a factor given of a large polynomial. Well, that factors to x plus 5 and x minus 2. So you're going to be setting up two-stage synthetic division with both of those factors. So if you know that, you can rip out one factor at a time and you're good to go. So you got quite a bit of practice in the workbook. This is, in my opinion, an enjoyable section because it just brings us back to our roots of division. And once you get into synthetic division, things become quite a bit easier. Don't forget that hidden factor. If you have a factor that is that, and you have to write it like that, like that you need to remember to include that factor of division in the end. But I hope this worked and it makes some sense. This stuff can be a little confusing, but it does all connect in the end. Thank you so much and see you next time.